Today, what I'm going to talk about is Arduino programming as it looks in the TinkerCAD Circuit simulator. We're also going to look at the sections of an Arduino program and some basic commands that will be really helpful. Most of what I'm going to talk about is also in text in our Canvas course. There's an Arduino programming page in our modules that talks about the different sections, which is what I'm going to start with. And on the very next page, it has a lot more important information like comments, variables, what goes in the setup section, digital, analog, read, and write, which I'm also going to talk about today, and some helpful commands. So all of that is also available in text version on our Canvas page. I'm going to go ahead and switch over to TinkerCAD Circuit Simulator here. So I have set up a circuit for us to work with. It has two LEDs, a button, and a potentiometer. And this will let us look through a bunch of different types of commands and see how they work. Now I didn't dry run this, so if it all falls apart, well, you'll get to see how we fix things too. So the first thing that I want you to think about when you look at a blank Arduino program is setting up a header section. This is a type of comment called a block comment in Arduino that looks like /* and then all your text goes in the middle, and then */ lets it know when you're done. Things that should always go in your header section are your name, the date, what the program does, analog versus digital and read versus write. And then it's a good idea to put a license in here too. So I use the Creative Commons license. Let's see if I remember them all. By attribution, non-commercial. So that means that if someone else is going to use my code, they need to say that I wrote it, and non-commercial, they can't turn around and use it to make money off of. There is nothing in what I'm about to do that would make money, but it's just a good idea to be aware of what you're okay with people doing and not doing with your code, and make sure you get that written down. There's also a page on licensing in our Canvas course. Okay, so that's enough of a header section to get me started, but you should always have a header section. Any program you write for your whole life, okay? Just get in the habit now. Okay, so some of the things I'm going to need are I'm going to need to be able to tell my Arduino board where I have things plugged in. So that goes down here in setup. Pin mode is me telling the board that I will be using a specific pin. So let's look, for example, at this one, pin 12. Pin 12. And pin 12 is attached to this green LED. So is that an input or an output? So an input is when I'm taking in information from the outside world, which is not the case. An output is when I am putting out information or a signal. In this case, if I want to turn on the light, I'm going to have to put out a signal, so a LED is an output. And that line with a semicolon. Okay, I'm going to start with just that much. I'm going to go down into the loop section, and now I'm going to try and turn the light on. Okay, so we have to decide if this is digital or analog. If you don't remember from class, a digital is on or off, high or low, one extreme or the other. It's like the light switch in your house. It is on or it is off. You can't like balance it partway in between and have it be half on, half off. It's a digital signal, it's all or nothing. So I'm going to treat this as a digital signal. I'm going to turn my LED all the way on, all the way off. So now I have to decide if this is a read or a write. So a read is when I'm getting in information, like from a sensor, and a write is when I am putting out information through a signal like this one. So an LED, a light of some other kind, sound signal, a motor, all of those things where we're telling them what to do. That's a write action. So digital write looks like this. I need to tell it which pin I am interested in sending that signal on. And in the case of digital, I need to decide whether it's going to be all on or all off, so high or low. So I'm going to say high, end with a semicolon. Okay, so this is not a very interesting program right now, but it is somewhat complete. Let's go ahead and start the simulation and see what happens. So I'm going to hit start simulation up here. Oh, and I did something wrong. What did I do wrong? In, oh, I think mode. Let's try that. Hey, there we go. It's important to put your capitals in the right place. I should have had a capital M on mode and I didn't. So I fixed that and then it ran just fine. Okay, so we can see that my green light turned on. And that's all, because that's all I asked this program to do. Not a very interesting program, like I said. Okay, so let's go ahead and stop this simulation and see if we can come up with something slightly more interesting. So maybe just instead of it turning on, I will have it turn on, or flash, turn on and off, blink, right? Blink, green light. So that is an inline comment. And an inline comment means it will only comment out or not be part of the program the things on this line after the double slash. And I put these in so that I know what I'm asking my program to do. In this case, I want to blink the green light. So I wrote blink the green light. So here, this line turns it on. So if we want it to blink, we'll need to turn it off as well, right? So that's also going to be a digital signal. I am still telling it what I want it to do, so that's right. It's still on pin 12, but now instead of high, I want it to be low. This seems like it would make it blink on and off. So think to yourself, if I missed anything, we're going to see where this goes wrong. I'm going to hit start simulation. And it looks like it's just on. That's not quite what we wanted. So why would that be happening? When your program runs, it is going to go from one line right to the next. So right now it's turning it on, off, on, off, on, off. Super, super, super fast. And that is resulting in it looking like it's always on. So what we need is some way to slow this process down. So I'm going to add a delay. And I'm going to do 500 milliseconds, half a second. Okay, so now I should turn on, wait, turn off, wait. And we'll go ahead and start this one. Okay, and now we can see our green light is blinking. That's good, it's what we wanted. Okay, now I'm going to show how to add a variable and why we might want to do that. So up here, before setup, I'm going to set up a number variable, an integer variable. Integer means a whole number. And I'm going to call it green LED. And I'm going to set it equal to the number 12. So why would I do this? I have plugged my green LED into pin 12, and so now I'm giving a way to record that. So I could go through and replace where I referenced pin 12 with green LED, and it would work just fine. What's the point of doing something like this? Well, let's just take a look. What would happen if I didn't want to plug this into pin 12 anymore? I want to move it. I want to move it to pin 13. So now, everywhere I referenced pin 12, I have to go change it to pin 13. Now, I only have it in 3 spots right now, but imagine this is a much bigger program. I would need to change it a lot more places. Instead, if I have this, and I reference green LED, green LED, green LED, and I run this, okay, my green LED is flashing. Wonderful, that's what I wanted. Now if I decide to move this back to pin 12, I only have to change pin 12 up here, and we're back to blinking. So I want to encourage you to use this kind of format, which the SparkFun Inventors Kit helps you set up as well, to keep track of the pins you're using. It'll just make your program a lot easier to keep clean and updated and readable. It's also really helpful because down here in this line now, I can tell that I'm trying to do something to the green LED because it's listed right there instead of pin 12. Maybe I don't remember what pin 12 was for. Okay, so let's stop this program. I think we have got the digital right. High is on, low is off. You have to tell it what pin you're affecting. So that is digital right. So I'm going to add some more variables up here. I also have a blue LED on pin 10. I have a button on pin 8 and potentiometer. It's a potentiometer, but potentiometer is a really long word. I don't want to type it over and over again. I'm going to call it a dial. And it's on pin 3. Okay. I'm also going to need to do the pin mode for each of those. The blue LED, that's a nice quick change. The button. So now the button is not an output anymore. It's an input. I'm going to want to read information from that button in order to use in my program. So it's an input coming into the program. With the dial, same idea. It is an input. I am bringing in information from the world around me. So it's an input sensor. Okay. So the next thing I'm going to do, I'm going to give myself some more space down here. Now I would like to step blink, we're going to call it that, the blue LED. So I gave myself a comment describing what I want to happen. That's good. Good practice, right? And I am going to first just do the exact same thing I did up here so we can make sure that our blue light is working all right. So blue LED all the way on, blue LED all the way off. So right now it's going to blink the green, then the blue, because that is the way that my code is set up, right? It says turn on the green, wait, turn off the green, wait, turn on the blue, wait, turn off the blue wait. And they're both working. I'm going to stop. Now that I know the green is working okay, I'm going to go ahead and comment out this whole block. So that's the /*, and then I find where I want that comment to end, */. So you can see in TinkerCAD that the comments are kind of this orange color. That means they're there for you, the program, to read, but they're not creating actions in the program itself. They're not sending a signal, they're not reading a signal, they're just informational for the programmer, not for the board. Okay, so it is oranged out now. So now if I run the simulation, only our blue light blinks because this is the only piece of active code. Good. Now my blue light is connected to a slightly different port. You can see that some of these digital pins down here have this little tilde, this little wavy line right in front of them. And what that means is they are pulse width modulated, or they can be treated a little bit more like an analog signal. Instead of only having the option of all on and all off, you can send a range of values in between. There's a little bit more on exactly how pulse width modulation works in our Canvas course. I'm not going to go into that right now. I'm just going to show you how it works from a programming point of view. So down here, I think I'm going to give myself some more lines so I can pull this up. Okay, so down here, instead of digital write, I'm going to say that I want to analog write on both of these. So if digital is like a light switch, all on, all off, an analog is like a dimmer switch, where you can be all the way off, you can be all the way on, but you can also be all the values in between. So you can be half on, half off, be 3/4 on, be just a little bit on. So digital, all on, all off, analog, all the values in between. So that's what I'm going to show here. I'm going to start with my analog write. So again, write means I'm sending information out to my LED. So analog, range of values, write, sending information. So my blue LED, I'm going to have it start at 0 and then go to, so for these, they're going from 0 to 255, multiples of 2. Again, look back at the pulse width modulation information, that'll help. So if I'm gonna go to a total of 255, maybe I'll go to 50. And then I'm gonna wanna do this a little bit more so that we can kind of step up. Then I'll go to 100, and then 150. I'll show you another day how to make this look a lot nicer. Okay, so right now it's going to start at 0, wait a half a second, go to 50, wait a half a second, go to 100, wait a half a second, 150, 200, 250, and then start back at 0. So let's see how we did. You can see it getting slightly brighter, down, brighter, 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 all the way out, brighter, 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 all the way out. Okay, so this is not a really great fade, but it is a little bit of a fade. You can see it building up to all the way on and then turning off. Okay, so that's how analog works. All right, so I'm also going to stop the simulation and comment this one out, because now we know that that part works. Excellent. Okay, so I have 2 LEDs. I have learned how to use digital write and analog write. I've also learned how to use delay, which waits for some amount of time. And now I'm ready for some sensors. So I'm going to start with this button. So a button, like we said, is either on or off. You can't half press a button. It's one or the other. So a button is going to be a good example of a digital read, because we're taking in information from that button. We're not telling the board what to do to the button. We're waiting for our user or the real world to do something to the button, and then we're taking in that information. So this is going to be our example of digital read. Digital read. And then we have to tell it which pin to read on, and our button is on pin 8, but we're just going to call it button. Okay, but we have to do something with this information. I'm going to show you how to do an if statement for it in just a minute. But first, I'm going to show you what I think is the most useful tool in Arduino programming, and that is the serial monitor. In the setup section, we need to tell the program that we would like to use the serial monitor. This looks like serial.begin. This is also listed in your Arduino programming right here under helpful bits, serial monitor, how to set it up. And then down in our program, in order to use it, we're going to do serial.println. The ln stands for line, print line, and that's so that we get our information on a new line each time instead of all strung together in this really long, hard to read band. Okay, so right now, if we read this line, what's going to happen is it's going to read what's happening with the button and then print it out in the serial monitor. That's all. So we're going to go ahead and give this a try. I'm going to hit Start Simulation. Now your serial monitor is down here towards the bottom. If I click that on, you can see that right now it's reading the number 1. Okay, number 1. Now if I go click the button, it's reading the number 0. I'm going to let go. It goes back to reading 1. So click really quick. Whoop. Or really slow, click, release. So a 0 is clicked, a 1 is not clicked. Okay, let's figure out what something we could do with that information. So this is a digital input. Maybe I want to use a digital output, like my green LED. So I'm going to say if, anytime you want your program to be able to make some sort of choice, that's a conditional statement, or that's an if statement. And its setup looks something like this. The thing that we're going to check goes in parentheses, and the thing that we want it to do goes in between the brackets. So the thing that we're going to check is we're going to have it do that digital read of the button. And then we're going to check and see if it's a 0 or a low. Either one would work. I have the serial monitor doing numbers though, so I am going to have it refer to the number 0 because that's what I'm going to see in the serial monitor. So this line says, please go read what's happening on the button. If it's a 0, what do I want to happen? Maybe I will turn on the green light. So that was digital, right, the green LED, high. So right now, if I run this, I'm going to go ahead and run it and we'll see what happens. If I run this, the green light starts out as off. You can see my button is reading a 1. When I click it, the serial monitor changes to 0 and my green light turned on. But when I let go, it turns back to 1 in the serial monitor, but my green light didn't turn off because I didn't tell it to. So we're going to add that part. Else, it just really wants to change my formatting. I really like this further step in, but it does not like it for me. Else, digital write, green LED, low. So we're going to give this one a try too. Start the simulation. I am not pressing the buttons. We got the number 1 and the light is off. If I press the button, the green light turns on. The serial monitor is showing the button reads 0. If I let it go, the green light turns off. Serial monitor goes back to 1. You can see on, goes away, on, goes away. Okay, doing good. So we have digital write, analog write, digital read. So the only one we're missing is analog read. That's what we're going to use this potentiometer for. So I'm going to actually leave this part because it will only be triggered if I click that button. I don't really need to comment it out in order to keep going, but I am going to keep going. So the first thing I'm going to do is I'm going to borrow this line, the serial print line. But instead of a digital read, I want to do an analog read. And instead of the button, I'm going to read the dial. And then I will print it out and see what we're getting. I am going to comment out this serial print line up here because otherwise it will just keep printing that and it will kind of clog up my serial monitor. I won't be able to see what's happening on the dial. Okay, so again, digital, all on, all off, like a button. Analog, all those values in between, like on a dial, a potentiometer. It can read a big range of values. So we'll see what kind of values. If I start the simulation, you can see right now that I'm getting a mess. I don't like those values at all. I wonder what I did wrong. Dial 3, oh, I bet it's looking on analog 3. I'm gonna move this guy up to 6. And I only have to change that up here instead of everywhere. And let's try that again. Nope. Oh, I think I am missing my resistor. This is an excellent time to go show you how to look up what you're forgetting. So if I go back to Arduino programming, I actually want to look at the SIK guide, and I want to look at the potentiometer because obviously I forgot something. These are all also linked in your Canvas class. Let's see, potentiometer. Nope, power ground, middle one goes to a port. I guess it just really wants to be on an analog port instead of over here on the digital side. I was hoping to keep it all on the same part of the screen for you, but we're gonna make it work. So this guy, this orange one, actually wants to get plugged into an analog port over here. We'll go see if that helps out a little bit. So again, because I have these variables set up, it's really easy to make those changes kind of on the fly. So that's definitely what I recommend. We're gonna start our simulation. There we go. Okay, so you can see I have my dial turned pretty much all the way up, and so we're getting 1023. If I start stepping it down, about halfway down, there's our 532. There's 409, 143, all the way down to 0. Okay. So now I have to decide what I want to do with this information. So because I have an analog read, let's do an analog write. Let's use our blue LED. So in this case, I want to analog write to the blue LED, and I just actually want to send it whatever I'm getting from the dial. So I'm going to introduce a new variable up here, int dial reading, or dial value. We'll go with dial value. Dial value. I'm not going to set it equal to anything right off the bat because I want it to just start reading from that dial value pretty much right away. So I don't need to set it up with a starting value. I'm going to go down and I am going to change a few lines here. I want that dial value to be reading what's going on the analog dial. So it's going to analog read the dial and save that into this value variable. And then here I can just tell it to print out that variable. And down here I can have the LED set to whatever the dial value is. And then I'm going to show you why that doesn't work in just a second. Okay, so what should happen is I'm going to analog read the dial, save whatever that number is to dial value, print it out so that I can see what it is, and then use it to set the brightness of the LED. So we're going to watch what happens. Except I did something wrong. Dial, serial, print. Oh, I forgot a semicolon. So here's a great example. It tried to run my program and it found an error, so it highlighted in orange, but there's actually nothing wrong with this line. The problem is on the line right before it. I forgot to put my semicolon. And so it highlighted the line where it had the problem. It was trying to run through and it couldn't run this line because I hadn't ended the line before it. So sometimes if you get an error, try checking just upstream a little tiny bit. Okay, let's try that again. Okay, where's my serial monitor? So, I'm going to zoom in up here a little bit. So you can see right now I'm at 0 and my light is off. And if I go all the way over to full power 1023, my light is all the way on. But my light is also all the way on at 737. And my light is all the way on at 552. If we want this to really act like a good dimmer switch, we need to bring those values in because our light can only go from 0 to 255. Bummer. So let's try taking that dial value and dividing it by 4. Okay, so now we can see all the way on is all the way on, all the way off is all the way off, but we get a little better control of the brightness in between. It's matching up a lot better with those values, which makes sense if you do the math. Okay, I'm gonna hit stop right here. Close my serial monitor, get myself a little space back. Oh, so one more real quick. I have this dial working, but my button still works too. See that? Button for the green, dial for the blue, button for the green, dial for the blue. And that's because it's reading both sensors and only acting when those sensors do something, right? Which is probably a model that you're going to need to follow in your programs too. All right, this is digital versus analog, read versus write, how to set up variables, what goes in your setup section, how to make a header, what goes in your loop section, how to use an if statement, how to use the serial monitor. This is an awful lot of stuff to get you started on your own programs. There is text versions and examples available in Canvas, and hopefully this will set you well on your way. Okay, if you have any questions, you can let me know. I'm gonna stop my simulation. Oh, I was gonna show you one more thing. I'm going to share this and post it. So now that I have this example code, a wiring diagram for my example circuit, it's named something useful, I'm going to hit share. And I do not want to, I'm going to hit invite and then just use this link. Hit copy. And then anyone I share this with can also come in and see my code and my wiring diagram. This is the link that will go in your design doc. Okay. All right. That is it for today. You guys can let me know if you have any other questions.